Hi everyone. Oh, it is loud. I'm Liza Zasukhina from R&D IT at MSD. My team builds digital solutions for health economics and outcomes research. And together with my colleague Elena Meshkova, we are presenting today on building transparent and auditable agentic systems using open source R packages. The views are presented of our own. And this is the workflow that all of you are very familiar with. And deliverables in this modeling workflow today, or maybe I should say in yesterday's states, are mostly point-in-time deliverables. If we think about systematic literature reviews or models themselves, reports, right? So these are mostly single-use, point-in-time deliverables with little to no reusability. And most of these models today are built in Excel, and all the shortcomings of Excel has already been mentioned today, so I don't need to talk about that. And today, AI has already shown potential to touch many of the steps in this process, starting from evidence synthesis and reporting. And these two steps is, I believe, where AI has already proven to be useful. But what about modeling? We are working on this Agentic AI modeling platform. We started thinking about it quite early, I would say. We are definitely not the ones that built a working system early, but we are still working on it. And the platform is for model development, and we will expand into reporting later. So, as I mentioned, many people have already been thinking about it deeply, but the key differentiator in our system is, I believe, that we developed this modeling specification abstraction in YAML format. We chose YAML over JSON because it uses less tokens. And we made a deliberate choice to not ask AI to handle math, because math has already been invented. So we give it to open source, community supported R packages. So we do believe that this system makes it transparent, auditable, reproducible. So yeah, all the good things. Let's see how it actually works. The green boxes is like no AI. AI does not touch them, so all deterministic. And the purple boxes is where we actually use AI. So it all starts with textual input, can be a specification given by user in form of a short text, but can also be a publication or an HTA report, say ICER on ICE report. We worked on replicating them. We'll show a little bit later. Then from there, AI agent picks it up and creates, or it extracts the model structure. It comprehends the document, it extracts the model structure, and it also parses the available input data from this document. And we create this human and machine readable YAML specification. Then later is being routed into simulation engine selection. For example, for cohort Markov models, we use HEMOD. For patient-level simulations, we use HESIM. We also tried integrating PyDice package for running models in DICE. And in the future, we plan to develop a proprietary Mathematica package for dynamic transmission models, but that's still an idea. I'll talk a little bit about quality checks. The first quality check is rule-based no AI. We just check the input data from the source. We just check, for example, parameter bounds, simple. And the second QC, we ask AI to sort of validate the results again against the source. And then we produce outputs in forms of charts tables. We did a very small proof of concept. We can output an Excel model with formulas, but we didn't put too much time into that yet. And users can as well download R and Python code with objects, and they can take it away and run it, say, in their RStudio in IDE outside of our platform. Again, hopefully to make it as flexible as possible and as transparent as possible. From there, I will hand it over to Ilyana, who is online. So let's see how that works.
Hi, everybody. Can you hear me well?
Yes.
Okay, let me continue. So here we are presenting one of the use cases that we have been working on, which is about taking a publication, an ASH report, and trying to extract as many information as we can for it using AI, basically very heavy cloud AI, and transform it to a YAML model specification that you can see in the screenshot on the right. So for us, a YAML specification is basically a Lego blocks where you say, I have a Lego block of a state, or I have a Lego block of a cost or utility. And then you fill it in with details that you extract from the paper. And you say that for this paper, I know that I have 5 states, judging from the diagram, and I have costs that I find in table X. And like this, you create your YAML specification, which is model agnostic. It's a declarative language, so it's basically we have our own modeling language that has such things that if we have a state, is it applies to all scenarios we simulate, or by any chance only some of them. Okay, state maybe is not the best example, but for example, adverse effect. And after that, once we have our YAML model specification, basically once we have taken this Lego blocks that we have defined as a special specification and built a model of it, so basically a Lego castle, we can now try and simulate this model that is shown on the next slide using one of the simulation engine that Liza has been mentioning. So for our case, for cohort Markov models, we have been using HEMOD from R, which basically we try to use as much of this package as possible to rely on already proven good math that wouldn't be screwed up by AI hallucinations. And we provide an interface of it, which basically would translate YAML and these specifications in YAML, or you can think it as JSON objects as well, not big difference, programmatically would translate it into HEMOD objects. And this will have the pipeline would contain 4 stages. So first we are parsing YAML, making an object out of it. Then we are basically converting everything in the HEMOD state, so we can do ARM-specific simulations of different scenarios or different comparators interventions. Then we do the simulation, so calculate all the usual stuff, traces, costs, utilities, you name them. And at the end, also because HEMOD supports it, we can also optionally run sensitivity analysis, so DCA, PCA simulation, also based on the components specified in YAML. And then we output results, which some of them are presented in the next slide, as JSONs for now. And basically then these JSONs can be interpreted in any way how it's convenient. For us, we have a GUI front end that still use Plotly libraries, also popular in R, but we have done the GUI in React to output our results. And also we use AI to generate interpretation of these graphs, as you can see on the left. On the right, there is a sample of accuracy of the model replication that we can achieve. We can't guarantee that it's absolutely everything is captured great, but absolute numbers do correspond. So so the approach is promising, and we are usually within 5% of accuracy after several iterations of, extract data, look at it, adjust something, ask AI to improve, etc. And also to say that it's not only we can have only one simulation engine, but several. We did the first experimentations with another R open source package, HESIM, for the individual simulations. Basically, after that, we did very, very simple. We did very, very simple individual simulation, micro simulation models, and it starts the same as CMOD, but after that it obviously diverges. But we could get promising first results and individual pair traces from the users. Obviously, some math needed to be done to convert static probabilities into the format that HESIM approves, but that's our details, and it's okay for the experimentation. Thank you. What we believe is a good thing about our approach is that we have full transparency. So basically, whenever there is a model generated in YAML, users can always download and look at YAML. They can see it, the visualization in the GUI. But also, whenever, for example, a HEMOD object is created, they can download it, look at it, if needed, modify it, and simulate it already from there, not dependent on our platform. I think that's it from my side, Liza.
Yep. I'll just summarize and walk you through the next steps that we have for this project. So one thing to take away is that we want AI to handle the tedious, the boring parts of the process, like data parsing, validations, etc. And we would like R or other community-supported packages to handle the math. Then we also chose YAML for creating model specification as a format for our model specifications, human and machine readable. So we are not the first ones to replicate a nicer or nice report, but we have proven that with our approach we can also replicate an HTA report. We will continue using the same pipeline, and we'll expand into multiple simulation engines. Speaking of the next steps, it's all about depth, breadth, and maturity. So we will expand the model types. We will add reporting. Currently it's a proof of concept, so we will put some effort into making it a production-ready system. Multi-user collaboration or audit trails, and given that we used AI quite heavily, so we probably need to rewrite a significant portion of this application. And I believe the key will be a good user experience, truly. I think that's what will help us with adoption and uptake of usage of this platform. Because with AI, creating interfaces, creating systems is getting much cheaper than it was before, but user experience will be the differentiator. So we will be thinking about that a lot in the future. And that is it. Thank you.
Great. Questions? Yeah.
That was really interesting. I've got a few questions because you did touch on YAML a lot, and the main reason you gave for that was tokenization reduction. Have you explored kind of using other parsers, so like JSON or Markdown? and then compared that with other ways you could save tokens a lot more easily. So like caching, so where you save calls to your computer instead of having to recall the LLM, or other stuff such as which model you're actually using, because like Haiku could be more than suitable as an agentic background. Just don't know if you've considered those things.
Yeah, thanks.
So for sure, we have considered JSON, but it depends how you structure JSON. It can be up to 45% more. Markdown for representation of structured data, I personally don't like. So that's why it's YAML. But again, sometimes we use JSON, for example, for now for reporting of the graphs or the data that will be visualized on the front end. We didn't go difficult way.
Yeah, and maybe one thing to add, we made this decision like maybe 8 months ago. And then after we made the decision, we then did not do the extensive comparison. And 8 months ago, it seemed like YAML does use fewer tokens than JSON. I know since then there are other techniques how to optimize your token usage, but we've already made this decision. So, don't know if that's a good answer.
Okay. Any more questions? Any online?
Thanks. I'm quite naive to the world of agentic AI. You say that, yeah, YAML uses less tokens than JSON. Could you give an idea of the impact of what using less tokens actually means in terms of like obviously cost gains or efficiency gains and the scale of this? Like why is it important to use less tokens and what's the scale of that importance?
Monetary concerns, just money, right? Less tokens means less money. So
how much, like, is it a massive amount of money or a small amount of money? Obviously to some degree where you make an informed choice as to YAML versus JSON, but like how much does that choice actually have? I honestly have no idea, so be interested to know.
I don't have it from top of my head, but it also depends heavily on the usage, right? In our case, actually that's a good point. In our case, I don't know if the difference will be massive, probably like in hundreds of dollars, maybe up to like thousands of dollars. So it heavily depends on the usage. I would guess in hundreds of dollars, to be honest, say annually. But there are some comparisons online, and yeah, tokens are not cheap generally.
I think the story is that, again, it's now the world is changing extremely fast. And now maybe the driver is not only number of tokens, but for example, which model you plug in. The story which was not there, for example, half a year ago to that extent. Because now we all know how models differ in their performance and smartness. And for example, if one analyzes the paper, there are a lot of computation goes to analysis of the paper itself. So after actually my personal belief that once you have a stable model that is co-created with the user using AI, because as online was written in questions in the chat, without human curation, it's nothing. That's why, for example, our system has a very rich GUI. Also to visualize, the models not as a program language, then the model might react, bring actually very heavy addition to the costs, not only tokens. Thank you.
Thank you.